All right, let's take a look at the following question. We are asked to find dy dx given that y is equal to the square root of sine square root of x. All right, so let's have a look at this one over here. If I want to find the derivative of this function, I need to remember that the square root also means to the power of half. So this is going to be equal to sine of x to the power of half, and the whole thing is actually raised to the power of half. And I cannot multiply those two units. It's not a power. It can simply multiply by it. This power actually belongs to that x only. It does not belong to the sine, but this belongs to the sine. Okay, so if I want to derive this, I'm going to use the concept of the chain rule. And the concept of the chain rule says that if I've got a function like this, which is actually like f of g of x, root x is a function inside a function of sine. I'm going to treat the outside as a function. Maybe let's say I use the u method. I say let u equal sine x to the power of half. All right, that's the inside. So therefore, I know that y is going to equal u to the half, because that's the inside. And when I derive this using the power rule, dy dx, the half goes to the front, and then half minus 1 is negative half. So from this here, I'm going to end up with dy dx equals to 1 over 2 times the square root of u, or u to the power of positive half, expressing the, I'm just rewriting this as a positive power. Okay. So now I've derived this function, I've got dy dx. The next thing I'm going to find is du dx. All right. So let's say I calculate that over here. So what is du dx? I'm going to derive this with respect to x. Firstly, I've got to derive sine x to the power of half, which is going to be cos x to the power of half. And because of chain rule, I would multiply by the derivative of x to the power of half, which is times half x to the power of negative half, like that. So cos x, cos root x multiplied by, now this is going to go to the denominator, so I might as well put it below, and square root of x over there. That's x to the power of negative half, and it'll go into the denominator, which means I can just go underneath like that. So that's du dx. This is du dx, and this is dy du, actually. This is not dy dx, this is dy du. Now, I have used an intermediary du. So I'm going to split this up. I'm going to say dy dx can be found by splitting these two up. And I'm going to put dx over here at the bottom and dy at the top, so that I can bring in du like that. Because that'll cancel out. And ultimately, if you treat this as a fraction, it will basically cancel out. Those two will cancel out. And now do have to do that. Now, I got dy du. All right, that's what's supposed to be the slip, right? Which I can obviously finalize now, because this is 2 times sine x to the power of half. All right, but it's u to the power of half, right? So this is u, there's going in there, to the power of half. Okay, maybe I should have kept it in third form, it would have been easier. But I'm going to bring it in anyway, like this. This is going to be changed into third form just for convenience of viewing. So I've got the square root of sine the square root of x over there. And on this side here, multiplying it by du dx being this part over here. So it's simply just multiplying by cos root x divided by 2 root x, like that. Because that is du dx, and that is dy dt. And nothing needs to cancel. We've now found dy dx. We just need to simplify it into a single component. So cos root x over 2 times 2 would give you 4. The root x can multiply into the bracket and become x sine root x. But the square root remains as is. I could rewrite it in many different ways. I could do the root x on the outside. Can't really simplify this entirely just yet because I can't even say cos of a sine is tan because the sine is attached to some root of here. If this was also root, then maybe I could have had some kind of tan. If this was also root, then you can see I could have taken the x out and then made this into cot x. But I can't do that. So this is all to the power of a half, and this is not to the power of a half. I can't even subtract it because they have different bases. So we can stop here for this question. All right, the next one. Find dy dx given ln y equals sine to the power of 3x plus 4. All right, try this one. See if you can try it first, and then we'll go through it. All right. The first thing is I'm dealing with the natural logarithm. If I raise this to the power of e, and I raise this to the power of e, we know that's going to cancel out, and I'll be left with y equals e to the power of sine cubed 3x plus 4. Okay. And if I find dy dx for this, now, I know when I derive e, it remains the same, right? So it will stay exactly with the same power. But I will multiply it by the whole thing. Okay. Right, so which means that I would have to take sine cubed in front. This seems too simple right now. E to the power of sine cubed 3x plus 4. So for example, if you had e to the power of 2x and you derive it, it would become 2e to the power of 2x by simply multiplying the coefficient of x. Now, why am I doing something wrong here? Why am I doing something wrong here? Because we don't have a coefficient of x over here. Because x is going down with it in front. There's it over there. Right, so x is actually over there. So the next question is, okay, well, maybe I need to get x on its own. So how do I do that? Let's rethink this now. On the left-hand side, I've got ln y. I want y to be alone so I can get dy dx, and I can derive it quite clearly. If I had followed the same pattern though, if I had followed this exact same pattern and continued in this way, I would have to use the chain rule, right? Now what if I did dy dx on both sides? Would that be okay? Here I'm deriving y with respect to x, here I'm deriving y with respect to x. And we know that when you derive ln y, right, the derivative of a natural logarithm is 1 over x. Now, the question then I could say is then, okay, well, this has y in it. Maybe I make each part separate. What if I make each part separate? Okay, I'm going to try something different here. So let's suppose I take ln y, right, and I make it equal to some function. All right, and I need to derive, I'm thinking of deriving this dx dy, which means with respect to y, so that I end up with 1 over y. Okay. If I derive both sides with respect to x, this does not have x in it. This has x in it. I can derive that with respect to x. So how do I go about doing this here? When in doubt, we use the u method, right? We use the u method. So if I say let u equal even y, then I know that du dy is going to equal 1 over y. And therefore, I'll end up with u equals to sine cubed 3x plus 4. And if I go du dx now, because I can derive u with respect to x, I can now quite clearly see I can derive this, right? This is the same as sine 3x plus 4 all cubed. So I'm going to bring the 3 to the front using chain rule and keep the sign as it is, subtracting 1 to get to 2 at the top, and then multiplying by the derivative on the inside using chain rule, which will be cos 3x plus 4. But when I derive this on the inside, it has a function. Deriving sine 3x plus 4 will become cos 3x plus 4, but then you still have to multiply it by the inside. You still have to multiply it by 3. So sine becomes cos, and then 3x plus 4 becomes 3. 3 times 3 would get me 9. And now I've got 9. And let's write cos 3x plus 4 in front. Times by sine 3x plus 4 squared is du dx. Now I need to definitely change this up a bit. So this is going to be dy du times du dx. And I've got du dx over there. I've got to get dy du. Well, guess what dy du is? It's just this flipped around, right? So dy du is going to equal y over 1. So I've got dy du, which is in terms of y. And I've got du dx, which is in terms of x as well. Let's just substitute it in, and let's see if we can simplify it, and if we need to go any further in that. So from this here, I'm going to substitute dy du, which is y. I'm going to multiply it by du dx, which is this whole thing over here, which is going to be 9 cos 3x plus 4 sine 3x plus 4 all squared, squeeze into that corner over 1. Not sure why I put it in the fraction. And then this y over here, remember we can find by raising this to the power of e. And if I do that, y is going to equal e to the power of sine cubed 3x plus 4 times that whole function there, 9 cos 3x plus 4 times by sine 3x plus 4 squared. And that is the derivative. Can I simplify it any further? And that doesn't look like it. And that would be my final answer.